Assalamualaikum and good morning, doctor. This is my group project assignment. We pick titration level 2 for our assignment. So the titration level 2 is about an acid-based titration of aspirin. So the group members are Tanjing Suan, Anisafia binti Muhammad Amin, Nurhanis Khalisah binti Muhammad Zamani, Siti Khadijah binti Nasir, Ani Ahmad Imran bin Ahmad Basri. So the chemical name for aspirin is 2-ethanol-oxybenzene carboxylic acid. So this is the structure, we can see it here. The structure contains of carboxylic acid group, phenyl group and ester group. So this is the second structure. It is divided into 3 groups. So the titration is about between weak acid and strong base. So aspirin is the weak acid and sodium hydroxide is the strong base. The weak acid will partially dissociate in water. It will form an equilibrium mixture between carboxylic ion and hydronium ion. The objective of this experiment is to determine the percentage of aspirin in an aspirin tablet and make sure the tablet does not have more than prescribed amount of active ingredient. Because if the tablet have more than the prescribed amount, it might turn into something bad to the patient or the one taking it.
Before we start this experiment, we need to prepare 10 tablets of aspirin, 0.1 mol per dm³ sodium hydroxide solution, water, phenolphthalein indicator, mortar and pestle, 250 cm³ volumetric flask, 100 cm³ beaker, 25 cm³ of volumetric pipette, wash bottle with distilled water, burette, filter funnel, droppers, detox stand with clamp, and pH probe. In this titration experiment, 10 tablets of aspirin are placed into a mortar and a pestle is used to grind the aspirin tablets into a fine powder form. Next, the aspirin powder has been transferred to a beaker and the water is added to the beaker and aspirin powder is being dissolved. Of course, the mortar also has been rinsed with water to ensure that none of the aspirin powder has been lost. Then, this aspirin solution is being transferred to this 250 cm³ of volumetric flask which has been rinsed with the distilled water. Filter funnel is used when we transfer the aspirin solution into the volumetric flask. The beaker is added with water again to dissolve the aspirin that is left over here and is transferred to the volumetric flask. And the volumetric flask is swirled to ensure that the mixture is mixing well. Then the dropper is used to drop a few drops of water to get a precise volume of aspirin solution. So we need to drop the water one by one and dropping slowly to get the precise volume of the aspirin solution. Then 100 cm³ of aspirin solution is transferred from the volumetric flask to this beaker. So now we need to obtain a 25 cm³ of aspirin solution from this 100 cm³ of aspirin solution. So we need to use this 25 cm³ volumetric pipette to transfer out the 25 cm³ of aspirin solution. So first, we need to rinse this volumetric pipette with the aspirin solution first and make sure the inside is fully rinsed before emptying it into the waste beaker. So after we rinse it with the aspirin solution, and then we only transfer the 25 cm³ of the aspirin solution into another beaker. So make sure the volume is precise and remember to line up the bottom of the meniscus with the mark. And then we only transfer the 25 cm³ of the aspirin solution into another beaker. So now we need to set up the sodium hydroxide solution in this burette. This burette is placed on the retort stem with clamp, and we need to rinse the burette with the distilled water first before we rinse it with the sodium hydroxide solution. As a safety precaution, always make sure that our eye level is always on top of the burette. So the burette is rinsed with distilled water first. Next, filter funnel is used when the burette is rinsed with the sodium hydroxide solution. Next, we need to fill up the burette with the sodium hydroxide solution. So we need to close the tap when filling the sodium hydroxide solution into the burette. Remember to remove the filter funnel to ensure the fuel level remains constant. So, the pH probe is used to identify the suitable indicator that we are using in this experiment. Based on this titration curve, we can know that the endpoint region, and we can know the suitable indicator that we are using in this experiment. So based on the titration curve, the suitable indicators are phenolphthalein and bromothymol blue. Next, a few drops of phenolphthalein is added to the 25 cm cube of aspirin solution that we prepared just now, and the aspirin solution is titrated with the sodium hydroxide solution here. And the titration is stopped when the aspirin solution started to turn pink. This titration is repeated at least 2 times, and the results obtained is recorded in this table. So that's all for procedure.
We need to do the trial titration first to get to know how much solution to be added into the flask. Record the initial reading of the burette, then click Start and continue add sodium hydroxide into the flask until the solution becomes pale pink. And once the solution becomes pale pink, click Stop and read the final reading of the burette. Record the final reading in the table, then record titer, which is the volume of sodium hydroxide added into the flask. Since the first titration is already given, record the titer of the solution. Then proceed to the second titration. Continue add sodium hydroxide solution until the solution becomes pale pink. And click Stop when the solution starts to become pale pink. And record the final reading of burette. Then record the volume of sodium hydroxide solution added to the flask. The titer is more than 0.05, so the solution is not confident. We need to proceed with the third titration and continue add sodium hydroxide solution until the solution becomes pale pink. And click Stop when the solution becomes pale pink. Record the final volume in the burette. Record the titer of the solution. Now the results are concordant because the titer is less than 0.05. Calculate the mean from the second titration and third titration and record in the table. We need to calculate amount of sodium hydroxide solution used in the experiment. So concentration times volume. And we need to determine the amount of aspirin and sodium hydroxide reacted during the titration experiment. Next, calculate the mass of aspirin reacted during the titration using the formula amount of aspirin times molar mass of aspirin. Then determine whether the amount of active ingredient in each tablet complies with quality standards. Throughout the experiment, we can conclude that repeating the titration for 3 times can help to obtain an accurate result. The amount of sodium hydroxide solution used in the titration experiment is 0.00189 mol. And the amount of aspirin that reacted during the titration experiment is 0.00189 mol. The mass of aspirin that reacted during the titration is 0.341 gram, and 25 cm cubic solution of aspirin used in titration contain 1 tablet. Lastly, the aspirin content in each aspirin tablet does not fall within the acceptable range as listed in the quality standards, which is 285 to 350 mg.